Hello and welcome to Lab 3, the black hole. In Lab 3, we are proposed the problem of simulating a star orbiting a black hole of unknown mass. We are given the mass of the star, its initial velocity, and its initial position, with the black hole being at the origin 0, 0, 0. And we are asked to analyze the position of the star to find the net force solely from the force of gravity using the black hole, and then therefore find the mass of the black hole. And this is over the course of 1 day or 8,600 seconds. The constants we are given in our code are the gravitational constant, the mass of our star, and then delta t, which is 1 day, 8,600 seconds. We are given the initial and final velocity using our starting information. And then from there, we can calculate the initial and final momentum. And momentum is simply the mass of the star multiplied by the velocity in vector form. Then using this, we can calculate both the delta V and delta P, in which you do final minus initial in the X, Y, and Z quadrants. Then we have to calculate delta dp dt, which is simply the change in momentum over the change in time. dp dt is also equal to the net force. And so in this case, we used the x and y delta p over delta t, and then set f net equal to dp dt. For perpendicular and parallel forces, we're asked to calculate the unit vector, which is simply the value in any part of the vector divided by the magnitude of all those values squared, summed together, and then taken square root of, which is the magnitude of a vector. And then using the magnitude of dp dt, we can then find dp dt parallel, and the magnitude of dp dt would be the final magnitude minus the initial magnitude over change in time in each part of the vector. And then to find dp dt, we multiply this by the unit vector to get its direction. And then we can set f net parallel equal to dp dt parallel because f net is equal to dp dt. And then using this, since we have found f net and f net parallel, we know that f net is equal to f net parallel plus f net perpendicular. And so we can find dp dt perpendicular and then therefore f net perpendicular. And then using all this, we can use the force of gravity formula to find the mass of the black hole, in which Fg is equal to gravitational constant times the mass of the black hole times the mass of the star divided by the radius squared. In this case, since we know the black hole is at the origin 0, 0, 0, we know that the position of the star is the total radius, and we can take the magnitude of that to find the exact radius. And from here, I can show you running of the code. And at the bottom, we are given our f net parallel, and f net perpendicular. And from here, we are asked, what is the difference between the rate of change in momentum and the net force? And in this case, the net force is caused solely by gravity of the black hole and is calculated by the change of momentum over time, which is the rate of change of momentum. Yet this is not all the net force is, because it's comprised of both the perpendicular and parallel forces. And in this case, the parallel force is the change in momentum over time, while the perpendicular force is always equal to mv squared over r. We were also asked what would happen if we replaced our current black hole with a new black hole of unknown mass, and if we could replicate the same black hole with a different mass. In this case, I do not believe that would be possible, as the path would not be the exact same due to a different mass having a different force of gravity,